Hey everyone, welcome back. This is Anif here. Today I'm going to discuss another important topic that is related to the system design, how we are selecting the databases, what is the principle behind the selection of databases. This is actually called the CAP theorem. Okay, this is called CAP theorem. CAP theorem. We are going to discuss not only CAP theorem, then ACID and base. What are they? How it is going to have an effect on the selection of databases. CAP theorem means C denotes consistency, availability, and partition tolerance. Consistency, availability, and partition tolerance. Okay, this is a triangle. In any database system, partition always will happen. Okay, we don't need to worry about the partition. Then what factor is deciding which database we need to search? Either it will be availability or it will be consistency. So we can call it as either CP world or AP world. Either CP world or AP world. What is the difference between CP and AP? Okay, if CP means consistency and partition tolerance, AP means availability and partition tolerance. Let's talk about what is consistency. Okay, consistency means in a database system there will be multiple nodes will be there. Every node see the same data. Okay, see or have same data. Then what is availability? Availability means every request gets a response. Next come to partition tolerance. Partition tolerance, that means keep running. Okay, this is what this three is. One is consistency, availability, and partition tolerance. In any distributed system, we can satisfy any two of them, not all three. Either it will be consistency and partition tolerance, or availability and partition tolerance. Partition always will happen in any distributed system, so we cannot avoid that. Let's go ahead and see if databases come between this AP and CP. Let's see the difference between acid and base now. Acid versus base. Okay, if it is acid in one end, then base at the other end. Base at the other end. Okay. What are the databases coming into ACID data? ACID means here this strict correctness. Here it is. Here it is high availability. Strict correctness is consistency and partition tolerance. Here it is availability and partition tolerance. This is CP world. It is called CP world. It is called AP world. In CP world, we can see There is a transition in this databases we can see. That is, if you move from one end to the other end, here we can see Postgres, PostgreSQL. There we can see MySQL. Then we can see here this PostgreSQL we can use for banking transactions. And we can see here MongoDB. It's a hybrid one. MongoDB is a hybrid one. Then we can see NoSQL databases like, in fact, MongoDB also NoSQL databases. More NoSQL databases like Cassandra, Sbase, and CouchDB, etc. Extreme left is consistency and partition tolerance, whereas extreme right is availability and partition tolerance. Here, this we can use for banking. MySQL we can use for e-commerce transactions and all. These are the trade-off between AP and CP systems, and what other databases come under this AP and CP systems. Let's go ahead and see this difference between acid and base properties. These are two philosophies. Acid means strict correctness. Here we can see the database which comes under the acid property. We use it for banking, e-commerce transactions and all. That is PostgreSQL, MySQL. In between acid and base, there are few databases out there that's called a hybrid mode. MongoDB is one of them. Even though MongoDB is a NoSQL database, it is considered as a hybrid from acid to base. There are pure base systems are also there, something like Cassandra, HBase, CouchDB, DynamoDB. So these are pure NoSQL databases. Those comes under this AP system. It is availability and partition tolerance. Let's go ahead and see what is meant by this acid property. Okay, acid means atomicity, consistency, isolation, and durability. Atomicity means all or nothing. Either all the transaction will happen or nothing will happen. Then comes to this consistency, moves DB from one value state to the other value state. Whereas in atomicity, we have write ahead log. Everything will be in the write ahead log. Either it will happen or it will be rollback. Here, consistency will be checked by this foreign key constraints. And isolation, that is, in isolation is happening through a raw level log. If you see the IRCTC example, Indian Railway, suppose we have two users, user 1 and user 2. They are doing the transaction. Both of them selected the seat. The user 1 has selected the seat first. Okay, he found one seat, he has selected. And he is updating the seat details. At that time, the row corresponding to that data will be logged, and he is doing the commit. Whereas for the second user, he came a little bit late, so his access will be blocked for a while, waiting in the log. And once this is committed, he will be getting error. Otherwise, he will get logged. This is how this isolation is happening. Let's see this transaction simulation for acid and base transaction. Suppose if I'm using acid properties or acid database, any database which comes under this acid property, just like Postgres or MySQL, I'm using this for some banking transaction. That means my bank is using this database in the backend. I have some amount, 10,000 rupees in the bank account. Account A, I'm going to transfer 200 to account B. Now account B is 7,000 credited, and here it is debited. The amount it is debited 4,000 here. Here that 4,000 has been credited. That means ledger is okay. That is sum of these two is still 15,000. Okay, it's unchanged. Ledger is same. That's why that's saying that this transaction has successfully completed and ledger is same. There is no difference. There is no disparity. If it is in case of base system, suppose if I am doing, if I account A is having 10,000, account B is having 5,000, I am transferring 2,000. It is debited 2,000. Account B got credited 2,000. It has become 7,000. It is synced. sum is 15,000. And suppose if something happened, transfer and crash. Okay, something happens during the transfer, it got crashed, but the account is debited here, it is not credited here. Now it got diverged. Ledger got diverged. That means the ledger is having A 6,000 and B 7,000. It is not that much consistent at all. Okay, then this is the difference between accident-based properties of databases. If you're using bank transaction, we have to use the databases which is coming under the ACID properties, or CP, consistency and partition tolerance. Here it is not consistent. We got, after the system crash, we got the data got diverged. These are the difference between acid and base properties. Then how this acid and base connect to this CAP theorem? Let's go ahead and see. Okay, acid and base database level implementations of the CAP trade-off. Okay, partition tolerance, anyhow, we have to do this partition of databases. Then the trade-off will be between atomicity, availability and partition tolerance. If, consistency and availability. If you're looking for consistency, that is CP world, then we have to sacrifice availability. If we are looking for availability and partition tolerance, then we have to sacrifice the consistency. We cannot have all three together. If it is a CP consistency, that is consistency and partition tolerance, then we have to follow the database, strictly follow this ACID properties. If it is AP, then those database will be following the base properties. That is CP plus ACID means we can use such kind of databases for banking transaction. Availability and partition tolerance plus base properties, we can use them for e-commerce or social media. And there are the examples. So PostgreSQL, Oracle, and MySQL are for CP plus ACID. Cassandra, DynamoDB, CouchDB, HBase, these are all for AP plus base. We can use them for e-commerce or social media. If you, let's go ahead and see one more thing. Let's see this partition simulation. Yeah, let's see this partition simulation also. In partition simulation, if it is a banking domain, okay, I have 10,000, node A 10,000, primary, and node B 10,000. I'll be triggering the partition. Okay. Partition. Let's see. Trigger partition trigger, unreachable. Here it is partition trigger unreachable. Write 5,000. Write refuse, no quorum. While doing this partition, writes are not allowed. Heal the partition. Now it is healed. Now, if you write 5,000, it will be writing to both the nodes. That is how this CP for banking transactions. If there is any active partitioning is going on, it won't allow to do any transaction. Then AP, that is availability and partition tolerance. We have 5,000 here, and trigger partition, it is partition unreachable. I can write 5,000. It is removed from here, and let's try to heal this partition. Now it is propagated to or populated to the node B. Now it is 0. Once it is healed, this transaction will be populated to node B also. This is this AP and CP level partition simulation. Let's go ahead and see a few examples for banking. Banking means CP, consistency and partition tolerance. This is architecture. ATM withdrawal, it will go to the load balancer. Banking API. API will go to the primary database and replicate the same to the secondary database or backup databases. Transfer flow, it will begin the log. A transaction will begin. It will debit from A, credit to B. The ledger will be validating. Once it is validated, it will commit and confirm. And during the partition, service temporarily unavailable because both the database has to be in sync. Whenever we do some transactions at database A, it has to be synced to the database B. If it is not possible, then it is not going to allow the transaction. When you come to IRCTC, architecture is user comes in. There is a AP layer always available. This tail okay, and train search, PNR status, seat display. Once there is a seat available, then then it will be moved to the CP layer. In IRCTC, we have both AP and CP. That is the beauty. In CP layer, we have seat allocation. Once the payment is done, ticket will be issued that particular user. The other user will be in queue, and once this transaction is finished, there is only one ticket, one seat. The other user will be get denied. This is the booking flow. Search, select seat. Once you select the seat, that will be locked for that particular user. Once this payment is done, commit is done, it will confirm the commit. Then the PNR will be issued that particular user who made the payment. Okay, so this is all about this ACID and base properties. Databases ACID plus base plus CP. PostgreSQL is a relational database. It comes under CP. Guarantee full ACID properties. Transaction. Full plus save points. That is finance ERP systems and all using Postgres. MySQL InnoDB. This also comes under CP. Oracle DB comes under CP. These are all full ACID properties. Then come to Cassandra. This is columnar database. DB is key value pair. MongoDB is document DB. CouchDB is new SQL. These are all comes under this Cassandra, and DynamoDB comes under availability and partition tolerance. MongoDB and CockroachDB comes under consistency and partition tolerance. Redis is a cache system that comes under availability and partition tolerance. Google Spanner, that is comes under the CP, that is full ACID. For that, this is all about CAP theorem. Thanks for watching this video. Have a good day. Bye.